Okay, so today's event is about building LLM-powered apps, best practices. So this is the third webinar we're having. As you see, at the beginning when we did the first one, I wasn't sure it's going to be regular. I'm really happy to see this is popular. There are people joining from all over the world. Time zone that's kind of okay for everyone and not perfect for anyone. So it's the idea is we're having a series of webinars which are supposed to be, about completing subjects, so that if you go through the different webinars, there's usually a recording afterwards, even though it's always less fun and less interesting. We might censor out the juicy stuff, so watch live if you can. But the idea is you're supposed to be able to be pretty good at at understanding the space and knowing what's more and less important after seeing these or hearing these, if you're somehow hearing it without video. So the idea is it's not aimed at the beginner level that much. Beginners can definitely enjoy it, but the idea is even if you have some experience building some LLM-based app, that you'll still get something new from these sessions. Not all the sessions will be the same thing, but in the meantime, we've been diving into a few different subjects. We had DStack here last time, and before that we had Databricks. And here it's a pleasure to be hosting Kacper from Qdrant. And the idea is to get some of the tricks and secret sauces that Kacper's learned through his experience in the meantime in this space, and so forth. Again, questions on Discord. The idea is that we'll also be able to continue to chat with you and see this also offline, not have everything erased at once. And we want you all to be active on the community, not only during events. So in general about the LLMOps.Space, the idea is it's a global community for LLM practitioners. What does that mean? It basically means you're not a user of LLM like all of us are, but you're building an app that uses LLMs in production, either more hands-on or more, in some role that's somehow defining what should be done without being hands-on. And then we've just grown to a bit more than 1,500 community members, and we're setting up some very interesting projects, like mapping the companies was the first one we did. At some point, we're going to start having launches of new products by companies here. We want them to do them here and not have to set up their own kind of private events, have different types of announcements about open source modules and so forth. So this is a lot of the actions on Discord. We also have the supporting website. And this is the list of basic companies. So you can see a lot of the interesting companies, including Qdrant over here. I think we'll somehow meet them one way or another within the community, within LLMOps.Space. And anything you think is missing here and so forth, feel free to send in offline. And a bit about today's agenda. So I'm sure Kacper is going to correct me and dive in a bit more, but the idea is we're going to be talking about the top available models, compare them a bit, see the advantages, and talk a bit about how to train them for those that you can train, talk about when you should and shouldn't fine-tune, talk about RAGs and specifically the context of what you're probably doing wrong if your RAG isn't working well, and then some other tools that you should potentially know, where of course that depends on time constraints if we get there. So a bit about you may already know me from one way or another. I'm a moderator here at LLMOps.Space, and also work with Deep, CEO of DeepChecks, that's doing continuous validation of LLMs and AI. The idea is making sure LLMs or LLM-based apps are doing what they should be doing. And then a bit about Kacper, which is the more interesting figure here today. So developer advocate at Qdrant, where they're building a open source neural search engine, and experience in a few different areas of this, which is always exciting for me, at least, to have data engineering, machine learning, software, etc. Talking to us here from Poland. And I asked him for some fun facts. I don't know if you knew I put them in the presentation, but he plays squash, which I actually also do. I'm sure he'd beat me, but we can definitely match up sometime when we're in the same country, and cooks quite a lot, where his favorite is Asian, which is Indian, Thai, or so forth. So if you want to speak like Kacper did at future events, then reach out. This is a simple link for doing it, but there are other ways to reach out. And now it's Europe.
Great. Thank you, Philip, for that introduction. Let me just share my slides then and hopefully start discussing the topic. Yeah, actually, one thing I should mention, I used to play squash quite a lot. Unfortunately, after the pandemic, I stopped doing it. I'm just trying to come back, but hopefully we can meet at some point and just play together.
Yeah, just excuses for when I beat him.
Yep, definitely. But well, we didn't meet here today for discussing different sports, but you wanted to hear something about building LLM-based applications, and I would like to share some of the best practices I faced. Some of them come from my personal experience because we do a lot of stuff related to large language models at Qdrant, but also some of them comes from our users because we also have quite a huge community of practitioners doing not only large language models, but also anything related to semantic search. And before I start, let me just introduce Qdrant for those who don't know the tool. It is actually vector database, aka vector search engine, which is mainly based in order to perform semantic search using vector embeddings. On the right-hand side, you can see the example of how deep neural networks may be used in order to encode sentences with exactly the same meaning into the vector representation. And those vector representations have a useful property because two different text images, whatever you want to embed, will have relatively small distance to each other if they represent a similar idea. So this is what all semantic search is about. And basically, this is also pretty useful if you create large language model-based applications. When it comes to Qdrant, this is pretty performant tool written in Rust, and you can interact with it using APIs such as HTTP or gRPC, but also we offer some official SDKs. This is open source, but we do have also our cloud. And if you just want to experiment, there is a local in-memory mode, so you can just easily switch from in-memory into on-premise using Docker containers or into our cloud if you prefer doing that way. And this is it regarding Qdrant. First of all, let me just ask you a question. Have you ever wondered why your LLM is worse than ChatGPT? Because I did a couple of times so far, and I couldn't really get even close to the quality of ChatGPT. And the answer is fairly simple. There are different ways of how we train large language models. And depending on the way you choose or the way that was chosen by the provider of a particular model, you may end up with completely different tool. As you may see, the pre-training phase is based on raw internet. So this is a bunch of data of rather low quality, but the quantity is huge. So there are trillions of text used to train the model. And the whole objective of the training phase is to predict the next token, because large language models operate on tokens, not words. And that's not exactly the same thing. We're going to touch it later on. But basically, if you do the pre-training phase, you can already have a model which might be deployed and might be useful in some scenarios. So there are models like GPT, Llama, and Palm, which undergo only that process. And there are also some other ways, like supervised fine-tuning, which is like fine-tuning the model after the pre-training phase using prompts and ideal responses to them. And there is also reinforcement learning with human feedback that is even more complex. And depending on the model that you choose, as you may see, Vicuna undergoes the supervised fine-tuning, but ChatGPT or Claude, model from Anthropic, are a bit more trained for a bit longer, and they are trained using this reinforcement learning technique. Basically, this slide comes from the State of GPT, which is a great presentation by Andrew Karpathy. So if you are interested, please have a closer look. But the main difference here is that...
I just want to say something about the previous slide. I know for some of the folks there, it might seem like a complicated slide. I want to say in some ways it's simplified, right? There are so many different options for what you can do when you're building an app, right? There's no like constraints to anything. There's like a lot of if else's different workflows. You can decide, you can start off by saying, okay, we'll have different models for different use cases and routing between them. So, it's not everything you would want even appears here, but this is some way to kind of show there are many different workflows.
Definitely, you are right, Philip. It's like if you choose a particular model, you should be also aware that it may not be working that well in a specific scenario, just because there is one part of training missing. And well, the last strategy is probably the best one, because the quality of the training data is also the best. But it also takes a lot of time to collect all the data. And if you prefer some simple means, it's also pretty fine, because that may work pretty well for some specific scenarios. And here is the comparison. The base model is just a model that went through this pre-training phase, and the whole goal of that process is to continue the document. So we provide the document, and the model predicts the next token continuously and produces the output. So if you just put a particular question as an input, you may expect some different similar questions being attached to the very end of that prompt. And that's basically it. If you do code completion tasks, this is pretty fine, because that may work out of the box. But the fine-tuned model works rather as some sort of question answering. This is more conversational like experience, more like AI assistant than predicting the next token. If you want to choose a model for a specific task, there are already some existing leaderboards. This is the one available at Hugging Face Spaces. As you may see, GPT-4 is thought to be the leader. Actually, it is a leader. But the one thing that I really found interesting is the last column here, which is license. If you want to do anything which is commercial and you cannot use third-party engines like ChatGPT or OpenAI in general, then you may end up with a model that has significantly lower precision, but still exposes it with a proper license. So as you may see, Apache 2 is, there's only one model with Apache 2 license, which might be really important if you care about data privacy and you want to have your model running in your own infrastructure. But this is great source of finding the proper model for the particular purposes, because not all the models are open source.
Is this worth saying about the table there? I mean, this is a big deal. Can you go back a second for the table? So you see, if all the top ones aren't really, open source, when you get to the, all the deep, like not only the default, all the top kind of second best are at best case Llama 2 community that will dive in. So that's a really big deal. So there's really a trade-off today, at least. The Llama 2 community is good enough for most purposes, but I think you'll touch the limitations a bit later on.
Yeah, I will. Definitely, like if you just start and want to create a POC or just try to experiment, then probably OpenAI models should be the first choice, because they're really easy to use and you can just connect to them using a simple API. So this is fine, but if you have some additional criteria, like you cannot put your data into a third-party system, your choices are quite limited. And there is also a difference between open source and open models. I wouldn't say that some of those models are open source, because they just share the weights. So this is like a tool that I would rather call freeware or freemium, just because you cannot simply see the data set that was used to train the model. So that's a real challenge, because that could have been trained using some copyrighted data, or there might be some bias that you cannot really check. And if the only thing that you have are the weights of the model that you can easily use, and probably the script that was used to train it, but you had no idea of what was the data, then it's quite hard to be used and fine-tuned further. Also, this is an issue with Llama 2 that is quite often discussed. If you have a bunch of users, like 700 million, which is quite a lot, I have to say, you need to have a permission from Meta to use that model. And you also cannot use Llama 2 in order to train a different model. So that might be a limit that might be like changing your decision while you are choosing a proper model to use in a specific scenario. But if you want to have a real open source, there are tools like Mistral or T5 or Flantify, actually, which are really open source, because they have a proper open source license, which is broadly accepted. There is also an interesting project called Platypus, but it cannot be used commercially. So this is it regarding the licenses. But if you choose a model, then you also need to know what was the training process, because the expectations are completely different. If they just do a pre-training, it won't be an AI assistant, and that definitely needs fine-tuning.
Yeah, wait. So 1 second before we dive into fine-tuning, I have a quick question about this for the audience, maybe a couple of questions. So first one, can you go back a bit? So
Yeah, sure.
who's surprised by this? Who knew or didn't know that there are limitations on the llama? So you can definitely raise your hand if you were surprised by this. I didn't know
Well,
this
I
from the
was
beginning.
surprised.
I was definitely
Also,
surprised.
like Meta tries to present Llama 2 as an open source model, but this is not a real open source. Like we have some open source licenses which are commonly accepted, like Apache 2, for example, and they have like completely different licensing. The completely different license. At the first glance, when you check the document, it seems like it is kind of similar, but it's not.
Yeah,
Well,
so
I wish some of your projects would be so successful that you would have like 500 million monthly active users.
yeah,
But
I gotta say, I'm sure a lot of companies say, we're not gonna have this problem, right? We're not gonna get to 700 million monthly active users, or if we do, then we have other problems, whatever. But it's interesting. It's interesting why it was needed for them, and it's also interesting if what like legal teams and due diligence will kind of think about this. So this is all one thing I wanted to say. Then basically for those of you that for some reason don't have video, the idea is there are limitations within the llama community license, which basically says above 700 million monthly active users, then you need a separate license, which we have no idea what that looks like, and I don't
yeah,
know but
this is a lot. Like
yeah.
there are just a few projects that may reach this number probably. But the second point is also pretty interesting because, well, the typical approach might be to train a different model. Like you have a data science team that may be doing that, and at some point they may just realize that they are just using, let's say they are using Llama or anything based on Llama, and they just want to train a different model and somehow use the feedback of Llama. Because this is quite often being done. Like we have two different models when we are just using the outputs of one of them to improve the performance of the other. And right now it seems to be prohibited. It cannot be done. So if you chosen Llama as your model to be used quite early, you may struggle with switching to a different technology at some point.
Okay, amazing. So now I'm going to launch a poll, and I'd love to start to see how people are answering. So the question where this is kind of a starters poll. We have one more poll after this. What's the current development stage of your LLM-based application? Just so we kind of know a bit about the audience.
Yeah, this is pretty interesting to know how experienced you are with doing LLMs. Like I have this feeling like it is relatively easy to build a POC or even a short demo using LLMs, but creating a real value, a real project that might be launched for multiple users at once is a real challenge. It's like with autonomous cars, it's pretty easy to do it in laboratory, like show that this works pretty okay, but well, at least in Poland, we do not have so many autonomous cars running on our streets, and that's not gonna change quite that soon, I guess.
Yeah, okay, so we gave it 1 minute. I'm sure there are other people that would still answer, but let's kind of end the poll now. So you can hopefully all see the results. I'll do the sharing the results. So we have 54 people that answered. So the most common is conceptualization and design, then development and testing, which is the phase where maybe you're comparing versions and so forth. Then we have production and deployment, which seems to me like it's the initial production and so forth. And optimization and scaling is basically, okay, we already kind of know what we're doing. We just want to make it cheaper, have more of the same thing and so forth. So very interesting. I'm not really surprised by the distribution. Of course, it's the space is new, et cetera, et cetera. But it's definitely it's definitely always fun to see the specifics.
Yeah, this is really great. I'm also quite surprised to see that there are so many people doing that already in production. So I have some different thoughts on that. But yeah, so maybe you won't be surprised by the some of the materials I prepared, but I think you can switch to the fine tuning, because that's another topic I wanted to discuss, whether we should fine tune the models or not. But first of all, before I start, there are different strategies how you can fine tune the model. There might be different ways of doing that, but they are all related to the training process of the LLMs that I presented before. Depending on how you can afford doing your fine-tuning, you may choose like self-supervised, which will be all about providing lots of low-quality data, and this will be still based on predicting the next token. But if you can afford preparing a data set of a good quality, then supervised or reinforcement learning based fine-tuning might be an option for you. But we usually try to fine-tune our models when we see that they don't work that well in a specific area or specific industry that we work for. So definitely at some point you may face this issue. There are different ways of how to overcome them, but there is one topic that I feel is quite vastly ignored, and those are the tokenizers that we use. Tokenizers are just some simple algorithms that convert the input text into tokens, and those tokens are really the input of the large language models. And if you fine-tune your model, let's say you have a model that works pretty okay, that works okay for English and pretty well for non-English languages that you also need to support, and you would like to improve the quality of their outputs for those non-English languages as well. If you do not change the tokenizers, if you do not change the vocabulary that is being used under the hood, you are not going to really improve that a lot. This is like a huge limit of the LLMs. But that might be also changed if you use any of those pre-trained networks as your base model. You can also adjust the tokenizer so it will support some of the words. That's a common issue. Like if you work with non-English languages, this is a pretty interesting distribution that shows what is the typical length in terms of tokens for different texts. And as you may see, this is pretty okay for English, Spanish, also Chinese. But if you work with less popular languages, you may be using a lot of tokens, because the typical approach is that tokenizers will split a single word into multiple tokens if they don't know that particular word. So that's also pretty important. Not only the fine-tuning, if you want to incorporate, let's say, some terminology which is specific for your domain, you should also include it in the tokenizer itself.
By the way, I think this is the second time we're quoting from Chip Huyen. So Chip, if for any reason you're hearing this, you should be proud. You're getting a good and shareable data.
Yeah, that's really like great blog. I really recommend reading it. It's really great source of insights for not only for LLMs but for machine learning in general. But you might be still wondering, do I really need to fine-tune the model? And the answer is, it depends, but usually that shouldn't be required unless you work with a really specific domain or a language which is not that well covered. And there is a different concept of retrieval augmented generation. So instead of asking some knowledge-oriented tasks, there is a risk of hallucination that we all know. You may convert them into language tasks. So instead of asking a simple question, you ask that question and provide a context. And that context should hopefully contain the answer for your question. So your model is not asked to use the internal states, the internal parameters it has, but instead it is asked to use the text you provided in order to find the proper answer and just rephrase it. So you can have a proper answer which is factual enough. And that process might be, of course, done manually. Like if you just interact with ChatGPT using the UI, you can probably provide the some documents, but it's not worth it in that case, right? Because if you already have some documents, you can easily find the answer on your own. But that usually involves a semantic search under the hood, and this is why Qdrant or any vector search engines is a tool that shines even brighter. Just because the prompts that we usually send to LLMs are natural language. It's not like a keyword-based phrase that we used to put into Google search bar, but it's rather a question or it's a real interaction that we would also have with a real human. So this is why semantic search works better, because it covers different meanings of the same, different meanings of different, the same meaning of different words. Some also want to extend the context window and put all the data that you have, but this is temporary solution. Like you could put a whole knowledge base of your company into a single prompt, But that gets really expensive. If you want to pay like $2 per each API call and also increase the latency just because you will be sending megabytes of data for every single request, then that might be a solution, but only for a really short period of time. If you want to have a proper solution, then you probably need retrieval augmented generation at some point, because you cannot be continuously upgrading and fine-tuning your model. This is a great thread from LinkedIn about some pros and cons of retrieval augmented generation over a long context window. If you want to check it out, I really recommend it. And Philip Schmidt is also a person which is worth following here. Basically, the answer is retrieval augmented generation works well and is much better than increasing the length of the window context size.
Okay, just 1 second. There was a question in the Discord about this, where I'm not sure how to pronounce it. Sagar asked what the thoughts are on RAG-based models. Working with RAGs works for small data set, but scale we see a lot of difficulties in chunking and so forth. So my answer, tell me, Kacper, what you think, is RAG overall in a lot of use cases where it's possible is a very, very good idea. I don't see a lot of cases where I say, oh, why did they go with that? Like it's not going to work. I think there's a lot of art. I think you're going to give some of the tips later on. There's a lot of thinking about what should be the chunk size and how do you store the, how do you vectorize it and create the embeddings, et cetera. And then a lot of times you need an app. Sometimes it means starting with, intent classification at the beginning, then maybe having a different workflow for each one. There are a few different ways to approach it. But all in all, I don't see a lot of use cases where I say, okay, you should be doing something else instead of this. I think it's not getting popularity because everyone's stupid. I really do see a lot of value in it. And in a lot of cases, if you do the prompt engineering well and other things well, it's a pretty good idea. And that's not something I say generically about a lot of techniques in like machine learning or LLMs.
Yeah, you're absolutely right. Those models are pretty doing great job in producing some texts, but they are not oracles that may know everything about the world and also your private data. So RAG is the best choice here. But also there are lots of challenges, and actually this is the next slide I'm going to present, because from my experience and from experience of Qdrant users, there's a lot of things that may be just simply done wrong. Semantic search is not that simple, and there are different problems you will sooner or later struggle with. Let me maybe just continue. I will describe those issues, but I agree.
Wait, one more important question you got about a past slide from Dimi in the Discord. So Dimi writes, I'm confused about tokenizers. When fine-tuning a model to work better with non-English language, can we use a different tokenizer, i.e. a different one than the one that was used in the pre-training?
I would say you shouldn't be using a different tokenizer, but you can easily extend an existing one. Definitely, it's not only about extending the tokenizer. If you just put some additional words into the vocabulary that is being used by a particular tokenizer, it won't know it. So you still need to do some fine-tuning, possibly with examples using those new terms, those new tokens that you just created. So you also need to do it. But it's not about changing the tokenizer completely. Like under the hood, each token has its ID, and this ID is actually seen by the model. So if you just attach some new ones, there will be some new identifiers created, and those identifiers should be also included in the fine-tuning phase. So there are like two steps which are related to each other, but that might be easily done. If you just drop me a message, I can send you a link. There is like a great thread describing how to do it for different models. And if you use some of those popular ones, this is fairly easy.
Right, but would it be fair to say that if you're fine-tuning with a different tokenizer, that you probably need more samples, right?
If you completely change the tokenizer, then it won't work at all. Like the mapping between the tokens and their IDs will be completely messed up, I would say. But you are right. If you just extend it, put some additional tokens, then you need some data, and the more tokens you put, the more examples you should have. Like if you just want to have a single token, then probably just a few examples would be enough. But if you are going to include a completely new language, then it's great to collect a lot of samples.
Okay, great.
Okay, but coming back to the challenges of RAG, because there's plenty of them, and I was personally involved in implementing a couple of projects using LLMs together with Qdrant for doing RAG, and those are the most common one, like the chunking strategy. If you use LangChain or any different framework, there are some defaults, like the default text splitter for LangChain is probably the one that just splits given text into chunks of the same length. That might be okay for some simple cases, but that's not that easy. Like if you have a longer piece of text that describes a single concept, it should be put all together. We were, for example, implementing a Discord bot, and it's not that easy to treat a single message as a unit which is enough to describe the context. People tend to put multiple messages just to describe the issue that they have. And also, if you want to have a full context, there might be some different messages sent in between. So you need to have a proper strategy of collecting the data. It didn't change a lot since we were doing machine learning for a couple of years, at least so far. And this is the same challenge that we had before. But you might be also using a poor embedding model. There are some models which are available out there. If you, for example, use OpenAI embeddings, they do not officially support multiple languages. They have some coverage for German, for example. I know that some other languages are also covered, but when I was trying to find the documentation describing which languages are supported, there is none. Actually, English is the only one which is officially supported. Some of the others might be just partially supported, and you never know. But there are plenty of open source models that I really encourage you to have a look at, like sentence transformers or even Cohere, which is another provider of embeddings using SAS model. This is also pretty great because they support over 100 languages. And if you want to work with non-English data, you need to choose a proper model. But it's not only about different language, but also different terminology that might be used if you work in a specific domain. But you might be also putting too many documents or too few documents into the prompt that you create, because that's what retrieval augmented generation is all about. You need to solve the problem of search, how to find the relevant documents that you are going to incorporate into the prompt. So if you put too many or too few, that might be a challenge. This is a parameter that we need to adjust. But also, I saw some interesting approaches of letting the model to ask for another part of data and combining that with a vector store just to provide some more information if the context that we already provided was not enough. And also prompt engineering. If you use the default prompts of the library of your choice, that may not work in a specific scenario. They are great for demos or great for POCs that you implement during the hackathon, but not in general. For some specific scenarios, you need to do prompt engineering right. Okay, and retrieval augmented generation is the default one, I would say, if you want to work with LLMs. But at some point, you may experience a need of fine-tuning. And this is the checklist that you should probably follow whenever you try to start fine-tuning your models. First of all, if your model is not able to produce responses in an expected way, I would definitely try out some different models which are available out there and choose the one that went through all the phases of training, for example, Claude, but also some other ones which were supervised, fine-tuned, because they should provide you better quality of the outputs. And prompt engineering is another part that should be also taken seriously. You should just play with different prompts, try to experiment and find the proper one that works well. And well, allowing your model to say, I don't know, is also an answer to that. But also retrieval augmented generation. This is a part that might be evaluated quite well. We already know some metrics which are commonly used for search, like DCG or an NDCG. And you can also use them for retrieval augmented generation just to find out if the documents that you return for your prompts, or for your queries are really relevant to answer that question. So if you see that all of those steps fail, then you should consider fine-tuning, but that shouldn't be the default. And if you decide to do the fine-tuning, there are already some existing tools. You shouldn't be implementing that from by your own. because you can choose a tool like SkyPilot, which is thought to be a state-of-the-art, which is an open source under Apache 2 license. This is a tool that allows you to run not only the training phase, but also the inference using different clouds, and they have a unified interface. So you can run your model on different cloud providers, those ones which are listed here, and it will just choose the best environment, the cheapest one to run your fine-tuning. It can use spot instances to reduce the cost of the training even up to 6 times. So this is great because you have a unified interface, and it works well with strategies such as Clora, which is about fine-tuning the model even on a single GPU, or fully shared data parallel, which is also a different strategy of doing that using quantized version of models. So this is a great tool that I strongly recommend having a look at if you consider fine-tuning. But if you already have a model, you have some tools that you want to use, you might be also wondering, do I need to use any of those hot frameworks which are available out there? There is LangChain, Llama Index, HiStack, but there is also plenty of others which are less popular. And
just Kacper, I know we have some limited time, and I know you have some more slides. So I think we should decide if we want to focus on this part or on the some of the extra tools at the end. 100% up to you. And we're going to do one more poll. I'll let you do another 1 or 2 slides. We'll do that other poll.
Sure. Yep. Okay. Works for me. Yeah. Basically, let me just briefly describe the issues that I see with using those tools. Because if you just use the default prompt, this is the default prompt. It's not a full prompt, but just like 1/3 of it that comes with LangChain. And if you see that your system starts to reply with Michael Jackson, even though there was nothing related to Michael Jackson in the prompt, you might be a victim of the default prompt. So you should be playing with the defaults. It's great to start with, but it doesn't work in all the cases. But we also need to consider moving to production. LangChain and all those tools are great if you just want to create a demo, but in production, you need some different means.
Okay, so I think now is the perfect time for the next poll. So I'm launching it now. All right, so you can see poll number 2. Which of the following best describes your LLM application's deployment environment? All right, because this has to do with moving to production, right? So of course, there's cloud-based servers with scalable resources, on-premise data centers, edge devices or IoT, and it could be a hybrid between cloud and on-premises, which means, usually it means that whoever's hands-on is trying to pull towards the cloud, and someone else in the organization is pulling towards on-premise, and then you meet somewhere in the middle.
Yeah, sometimes you have no choice, actually. I experienced that a couple of times. Like some huge corporates cannot really use clouds, or they're just limited to a specific one. So that might be a challenge.
Yeah. Okay, so we have 50 people that answered in the meantime. We'll give it another 6, 7, 8 seconds. Now's your quick time to, speak now or forever hold your peace. All right, so we'll end the poll. 52 people answered this. So you can all see it now. We can see 62% are, in cloud-based servers. I know some of you are on Azure, some on AWS. There are also some on Google, of course. We could do that for, one of the future events and kind of get more about that. But I think a lot of folks out there that are using GPT, I think, are having an account at least in Azure, at least for just the endpoint, even if they don't have everything on Azure. And here we're having a lot of representation of hybrid, which I hope is hybrid going towards the direction of cloud when it's possible. I know sometimes there are constraints and it can't be done otherwise. So that's 23%. And then, yeah, there are some use cases here of edge devices and on-premise and so forth, which is, it's always amazing to see how for these projects, sometimes just getting it to work in production, like technically, is like half the project. Yeah, back to you.
Great. Yeah. So you might be not surprised by the tool I wanted to present, but basically, once you decide to move to production, you have some other challenges to solve. Not only choosing the right framework and dealing with the default prompt, but real production system needs to solve some challenges that we also have with software in general, but also with machine learning models that we used to deploy in the past. And large language models are not that different. Probably you know some of the tools on the right-hand side, and some of them might be reused, at least for some of the purposes I mentioned here, but you need data set versioning, because if you fine-tune the model, you need to store the data and version it properly, but also model versioning, because you might be switching to a fine-tuned model at some point. But also model evaluation became a bigger challenge. Right now, some people try to use GPT-4 as some kind of benchmark just to evaluate their models, which is okay for the time being, but it means that we cannot beat GPT-4 by any means. We can at least like get closer to it, and that's not a real challenge. I know there are some other approaches to measuring the quality of large language models, but this still remains unsolved. And of course, prompt versioning became a thing. If you do prompt engineering, you might be switching the version of your prompt, because you may experience a better quality if you just put your request in a different way. So that might be all solved probably by some of the tools that you already have in your stack if you were doing machine learning before. There are also some interesting open source projects I want to share, like Guardrails, which is all about some sort of contract. If you do a big application that will interact with large language models, then you probably need that model to export the data in a specific way, like JSON. And Guardrails is a library that allows you to write a contract. So if the output of your model does not reflect the structure you want to have, it will automatically relaunch it just in order to make sure that the output is formatted properly. So this is a great tool, but still quite experimental. I'm not sure how many of you want to do LLMs on Edge, but there is an MLC LLM open source project, which is that actually enables running LLMs even on mobile devices or within a browser. So this is pretty cool. I have never done this actually, but at first glance, it looks really interesting. If you really care about data privacy and you don't want the data of your users to leave their smartphones, that might be a way to go. But also some personal assistance running on mobiles might be also achieved by those means.
Yeah, so from the poll, we know there are 3 people interested in that. Yeah, 6%, right?
Well, I would love to hear about your projects, which is, I've never experienced anyone doing that for real systems, so I'm pretty curious about that.
Okay.
But okay, and the other one, Fast Chat, which is actually the one that I wanted to mention most. This is really state-of-the-art tool. This is fairly popular, like over 30,000 stars on GitHub, I guess. It has some existing pre-trained models available, so the weights are already there. You can easily deploy the model that will be automatically exposing an OpenAI compatible API or Hugging Face generation API. So the interface will be identical to the one that you had while using OpenAI. So let's say you build a POC and then you want to switch to a different model that you trained on your own, or that you believe might be better than OpenAI due to, for example, data privacy issues. This is a great tool, which is open source under Apache 2 license. It has some utilities like 8-bit compression, but also 4-bit inference. You can also reduce the memory usage of that. It might be using multiple GPUs or a single GPU, but also CPUs to run those models. You have a web UI for quick experimentation. So this is fairly great tool that I really encourage to use if you are trying to find a good way of running your models. This is it. And that would be it regarding my presentation. I'm happy to answer your questions. If you want to stay in touch, here are my socials, and this QR code will point you to Qdrant Cloud and our free tier. If you want to do RAC, that might be the simplest way of doing that. We offer you a free forever cluster without credit card details required. So thank you very much.
Amazing. So it was a pleasure to host you here, and it was a very, very interesting angle, I think, on all sorts of areas that are kind of part of the workflow, but sometimes neglected. So I really like that direction. For any questions that you didn't have time to ask, during the event, or if you were just in the middle of doing something else or whatever, we can continue the discussion here on Discord. I do want to say there was one other question here by Shrut about Mistral, how that compares to the table you had at the beginning. I didn't want to bother you in the middle, but maybe you can, Kacper, you can answer that question. Any other questions in offline, feel free to either reach out directly or ask on the general chat. And see you at the next event.